Section 2.5, Truth Tables for Statements. In this section, we will learn how to write truth tables for statements that combine multiple operators. We will also learn how to write truth tables using three statements, P, Q, and R, and we'll learn how to translate from sentences to logical form and vice versa. So before we go into all of these things, just a quick note: the sign not is like a minus sign in algebra. It negates the expression it precedes. So if you write not P and Q, what you're saying is not P and Q. If your intention is to write something like that, not P and Q, then you need to use parentheses. So exercise 1, write the sentence in logical form. X times y equals 0 if and only if x equals 0 or y equals 0, which is a well-known statement that we use often when we solve equations in algebra. So we're going to write this in logical form. X times y equals 0 if and only if x equals 0 or y equals 0. And notice that we used parentheses. It's important to do so. If we didn't, it would mean something very different. Alright, the big thing today is to write truth tables, and it's kind of fun to do. So write the truth tables for the statement P or Q, then not P and Q. So when we have a long statement like that, we need to break it down into intermediate steps, and we need to figure out which operators happen first. In this case, P or Q will happen immediately, P and Q will happen immediately as well, and after that we'll have the not P and Q, and only in the end will we use the implication. So we're going to build truth tables using these intermediate steps, and you notice that in the table I provide, and I'll provide every time, there are several columns, and you can fill these columns as you want. Sometimes there's going to be too many columns, like in this example here. It may also happen that you are going to miss a column, so you're going to have to squeeze a column somewhere to solve your problem. So first we fill in the columns for P and for Q, so it's true, true, false, false, true, false, true, false. Then we said that P or Q can be applied immediately, so P or Q, we know it's on page 3 if you want to refer to it. The truth table is true, 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 false. Likewise, P and Q, also on page 3, it's true, false, false, false. P and Q is true only if P is true and Q is true. So once we've done that, we can now see the impact of the not. Not changes the truth values from P and Q. So every time P and Q is true, not P and Q will be false. If P and Q is false, not P and Q will be true. So true becomes false, false becomes true, false becomes true, false becomes true. Finally, P or Q, then not P and Q. This is an implication that uses our third column here and our fifth column here. So the implication table is on page 5, and remember that it is false only if we go from true to false. So in the first row, we are going from true to false, so our implication will be false. In the second row, we go from true to true. This is acceptable, so it's true. From true to true, true. From false to true is acceptable, true. And here we built our truth table for this statement. We'll now look at a second example, but this time there are 3 statements, P, Q, and R. So the first thing we need to take care of is how to build the columns for P, Q, and R. You can probably figure out that there are 8 different situations. The first one is when P, Q, and R are all true, 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 and we'll build them in a logical order that you should not deviate from. So from this true, 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 we will always try and change the last one first, and if we run out of option, we'll change Q, and if we run out of option, we'll change P. So here it goes like this: true, 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 false, true, false, true, true, false, false. And now we don't have any other options for P being true, so P becomes false, false, true, true, false, true, false, 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 true, and false, false, false. In fact, if you just think of the letters F and T, this is the opposite of the alphabetical order. TTT, TTF, TFT, TFF, FTT, FTF, FFT, FFF. It's actually easier when you are in a hurry and you want to build these columns quickly to look at them vertically. So P is true, 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 false, 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 and then Q alternates in pairs: true, true, false, false, true, true, false, false, and finally R alternates at every step: true, false, true, false, true, false, true, false. So this is a pattern we could also use if we had 4 statements: P, Q, R, and S. So let's go back to this: P and Q, if and only if not R. So the first thing we can do is P and Q. We can also do not R right away. And lastly, once we will have built these 2 columns, we can do P and Q if and only if not R. So P and Q is true when P is true and Q is true. If that's not the case, then P and Q is false. So we look at our first 2 columns. P is true, Q is true, therefore P and Q is true. Row 2, P is true, Q is true, therefore P and Q is true. P is true, Q is false, therefore P and Q is false. True and false is false, false and true is false, false and true is false, false and false is false, false and false is false. Now what about not R? So this not just flips the value of true and false. So we had true, this becomes false, false becomes true, true becomes false, etc., etc. So we end up with false, true, false, true, false, true, false, true. And finally, we need to connect P and Q and not R with this biconditional statement here. So we remember that the truth value is going to be true if it's true and true, or if it's false and false. So let's look at the truth values here. True, false is false. True, true is true. False, false is true. False, true is false. False, false is true. False, true is false. False, false is true. And false, true is false. So here we are, we finished building this truth table. Now, what does it really mean? Well, if we gave actual wordings to these statements P, Q, and R, we could think of what it means. Let's say we're going to look at this column here. P is false, Q is false, and R is true. So I'm going to say that P is 5 is even, which is clearly false. I'm going to say that Q is 7 is a perfect square, which is false. And I'm going to say that R is 10 is less than 11, which is true. I can conclude from that the statement 5 is even and 7 is a perfect square if and only if it is not true that 10 is less than 11, that statement is true. It wouldn't be obvious to figure it out, I think, if we didn't build a truth table. That's it for this section. Thank you very much.